All right, part 3, special types. Now we've already kind of hinted at these, so let me draw them for you. And I left some space out to the side for us all to draw them together. So here we have a graph. And I'm going to write an equation here. If I need that equation, Haley, give me an equation. Y equals 4x plus 2. Okay, so we're going to sketch 4x plus 2. Would you agree I'm close? Did I start at 2 and kind of went up 4 over 1? All right, ballpark. Now, give me an equation, Kyle, since you're sitting with Haley, Kyle, of another problem with the same slope but a different y-intercept.
Y equals 4x plus 6.
Okay, so here's plus 6. So now I go up to 6, but don't they have the same slope? So is the blue line ever going to touch the red line? No. So they have the same slope but a different y-intercept. So my question is, how many solutions? How many times do these cross? None. 0. So the answer to the first question is how many solutions? None. Or 0. Now, a different question. What is the solution? And Grace, you told me this before. What is the solution? I think it was you who said it. There are no solutions. So what is the solution? What did I just say? There are how many solutions?
0.
There are no solutions. So what is the solution? What do I write? No solution. What does no solution mean? There are no solutions. That sounds really stupid. All right, second scenario. Both equations are the same, but they're disguised. All right, what do I mean by that? Maybe one equation is y equals x minus 3. I go down 3, and there it is. But the other equation is disguised a little bit, and you have to solve it for y before you graph it. And so maybe the other equation is like 2y equals 2x minus 6. Do you see the disguise? It's all multiplied by what? Everything's multiplied by 2. It's the same equation. Now, if the slope is the same and the y-intercept is the same, how many solutions are there? How many? How many times does the blue line cross the black line? An infinite number. Now here's a different question. What is the solution? Where do the points touch each other? Everywhere on the line. They don't just touch everywhere, Luke, but they touch everywhere on the line. So the solution is the equation of the line. Luke, that makes sense? Yeah. Whatever the equation is, that's the answer. Because an equation, Haley, is just where all the points are that work for that line. All right, so let's look at these 4 scenarios down here. Decide whether each system has one solution, no solutions, or infinite. Do I have to graph these? All I'm doing is analyzing. Okay? Analyze the slope. What's the slope here? Circle it. What's the slope of the first one? Isn't it 3? What's the slope of the second one? 1. Are the slopes different? If the slopes are different, what does it look like? Show me with your arms. Is it this, this, or this? What do we got? This, parallel, same, or cross. Okay? So, how many solutions? 1. All right. 1 solution. What's your reason? Because slopes are different. That's all I need. All right, let's look at part B. Jalan, what's my slope of the first one? 2. Jalan, what's my slope of the second one? 2. Is that enough information to answer the question? It's either this or this. Good, Ryan. Which one is it? Why? Luke?
Because the y-intercept.
Good. These are different. Okay, so how many solutions?
0.
0 solutions. Because the slope is what? The same. What do I put for y-intercepts? Y-intercepts are different. Okay. Now, for number A and part B, I had nice, neat equations in y = form. Justin, that's not always the case. Notice on part C. See this 2y? To work this out, what must I do to this y? I must get it what? By itself. How do I get rid of the 2 in front of the y? So let's divide everything by 2. 2y divided by 2 is y. 12 divided by 2 is 6x. And 6 divided by 2 is 3. Look at your 2 equations. What are they? They're identical. True? So let's answer the question. Decide whether each system has 1, none, or infinitely many. Infinitely many. Why? Give me your because. Kyle, you're good at explaining things. Go ahead.
I'm bad at explaining things.
No, you're not.
What?
You're good.
Okay. Because.
Tell me about their slopes.
Well, okay, because they both have the same slope.
Okay, and?
The same y.
Yeah. Okay, the slope and the y-intercept are the same. Sure. Yep. If you walk backwards to go home and you walk frontwards to go home, do you still get home? The only point is getting home. I don't care which way you walk, but if you walk backwards, you might walk into somebody. All right, our last one. Can someone very easily help me solve this top equation for y? Did I ever teach you if something changes sides, it changes signs?
Yeah.
So if this x goes over to the other side, what does it become? A negative. Y equals negative x plus 4. What about this 2x? When that moves over to the other side, what does it become? It becomes negative 2x. How do I get rid of this 2 that's attached to the front of the y? Divide by it. So I'll write that in red. Divide by 2. Y equals negative 1x plus 4. So here's my top equation. Here's my bottom equation. What can you tell me about them? But what about this 1 in front of this x? It's the same as this one. This is assumed, right? So are they the same? So the equations are the same. So let's go back to our original question. Our original question says, decide whether it has 1, none, or infinitely many. What are we going to answer? Infinitely many, okay? So the answer is infinity. As you would say, to infinity and beyond. What was his name? Buzz, yes. Good old Buzz. So, all right. Now, I have tried, remember that old graph paper you had that was like really faint?
Yeah.
I've tried to give you some better new graph paper. So hopefully that is more functional for you. I apologize first semester, but I was able to create this for you. So here's our assignment.